Thank you everybody for joining our session. And today what we're going to be covering is the engine test that is going to be conducted. And this is really an onboarding session for us and for everybody to meet Sasha and Lindsay from bluShift Aerospace so that we can actually discuss this up and coming project. So what I'd like to do is before we continue, let's go around the room and let everybody introduce themselves. So I think let's actually start with you, Sasha, if you can introduce yourself, and then Lindsay after that.
Sure, I'm Sasha Derry. I'm the CEO and founder of bluShift Aerospace. bluShift was the first company in the world to have launched a rocket using a non-toxic carbon neutral bio-derived fuel. And we are hurriedly working to build and launch Starless Rogue, which I know many of you are anticipating, that will ultimately take up to 100 kilograms of payload. And we're shooting for is mostly researchers of the age of 21 or lower to be our primary customers on these rocket launches and so forwardly. So I'll pass it on to whoever you like next. Maybe I'll let Lindsay go next.
Sure. Yeah. Can you hear me all right, Judy? Cool. We're sharing microphone audio on Sasha's computer, so there's no feedback. But yeah, I'm Lindsay Becker. I've been with the company not 8 or 9 months or so now. But before that, I was working as a contractor for bluShift, making all their videos and photography. And now I'm sort of right-hand person to Sasha, helping out with marketing efforts and organizing group visits and things to engine tests such like this one. So I'll probably be communicating with anyone who's going to be coming up to Brunswick for an engine test.
Excellent, Lindsay. Thank you very much. Jim, can I hand over to you, and then Masa, let's go to you after Jim.
Sure. I'm Jim Gorman. I teach physics and chemistry and engineering over at Nipmuc Regional High School here in Massachusetts in the United States of America. So that's East Coast, about 3 hours south of bluShift. So they're within driving. So.
Excellent, Jim. I was just, before we go to Masa, if you wouldn't mind, once we've finished with our introductions, if you could just give us a little bit of background on your experience so far with your visits to bluShift and the activities that your students have gotten involved in. Thank you. Masa, over to you.
Okay. Masa Okutsu, I'm an engineering faculty at the Penn State Abington. It's a small campus in the northern suburb of Philadelphia. And then we have been working with Judy for the past year or so. And right now we are trying to see if we can measure the vibration using accelerometer. So that's a project that Ryland is working on.
Fantastic. Ryland, I think introduce yourself, and then let's go to Dr. Mensah from Cote d'Ivoire.
Okay, well, my name is Ryland Wolf. I'm with Penn State University under Dr. Okutsu, working on, as he said, the vibration, measuring the vibration of the rocket, and my partner, Akiata Peter Koi. He's not here right now, but he's doing other important work. So anyways, yeah, so we are currently working on that, and yeah.
Fantastic. Dr. Mensah, over to you.
Okay, all right. Dr. Mensah from Cote d'Ivoire, and I'm the president of the African Association for Technology and Innovation. I'm also a professor at the National Polytechnic Institute here. With this project, we are training students from different countries to use the MassIQ products for satellites, nano satellites. So we teach them every Saturday. We meet for 1 to 2 hours, and we talk about how we want to design satellites. Okay, so thank you.
Thank you very much, and I'm very pleased to be able to join us today.
Thank you.
Shay, let's go over to you in Michigan, and then we will cross to the team from Cameroon.
Okay, hello. I'm actually not Shay, I'm just on his laptop. I'm Jack Hammerberg. I'm the main engineer for our group. We are participating in the engine test. We also participated in the Cape Town launch and a few others. So we're aiming to collect images primarily with our kit. That was our main component that we were testing, was a camera and some other gas sensors and Adafruit sensors that we added on.
Great. Yes, Jack, thank you. Jack has been very, very active and very supportive on Discord. Before we did the project here outside Cape Town, I realized that Jack was probably pulling a few all-nighters, because we would get Discord messages from him of all times, the day or night. But Jack, it's fantastic. You know, I always used to say that, sleep is a waste of youth. You can sleep when you get to our age. So carry on going. Jim, can we hand back to you, if you wouldn't mind sharing with everybody? And I'm just going to put something into the chat for the Cameroon team.
Again, I'm from just 3 hours south of Sasha and Lindsay. And so my students were lucky enough, we were able to get approval to head up to bluShift for the cold engine test this past November. So that was quite fun. It was what, 7 seconds, but it seemed a whole lot longer than a 7-second demonstration, because there's a lot of stuff that goes on. Unfortunately, one of our devices, whatever happened, it shook loose or something, and it stopped recording data after a second or two. So we only got a little bit of data, but you know, you learn from those things, and the kids take a lot of those experiences with them. It really inspires them to do even more than they thought they could do. And so I actually have several kids now really chomping at the bit to get the Tiny GS going and all these different projects they want to do. So it's really been inspiring and helpful.
Great, Jim, thank you very much. What I'd like to do is, if I start sharing my screen again. Okay, so here we go. And Dr. Mensah, I can see that you've asked a question about the code. We're definitely going to get there, and we're going to cover that. We do have code from the previous test. Okay, so what I'd like to give a little bit of context here to this this engine test. So this is a graphic that we've put together, really, where we have a look at different altitudes and the destination roadmap, as we call it. With the destination finally one day being Mars. And all of the different things that we need to learn in order to get there. And so what we have is we have a model rocket launch, which we actually, we're in the final stages of designing at the moment. We have low altitude balloon launches. Daniel Lee, a number of you who are on this call today, a number of you have a launch with Daniel Lee on the 16th of April for your payloads, and those payloads actually need to be then integrated so we can use exactly the same payloads on the engine test. So Cody is sitting up very straight about this whole thing. High altitude balloon, with a typo, so I need to correct that. Isn't it amazing how you never pick these things up until you have to present it? The suborbital rocket launch. So what we've done is we have booked multiple payloads with bluShift Aerospace, and in terms of their suborbital launch. And what we're going to be doing is these engine tests are a really crucial stepping stone to understanding how our payload's going to behave. You know, Jim, as you said, you know, something shook loose. You know, so we need to make sure that that doesn't happen again. And it would be such a pity if it had shaken loose on a suborbital flight. Rather do it on an engine test on the ground. And then we have orbital launches. Sasha, maybe in a few minutes, if you just want to share with us your development roadmap and your pathway. We've had some experiments on the International Space Station. Probably going to go back there at some time soon. We're just trying to arrange that launch. Geosynchronous orbit, we're probably not going to do it. It's really far away. But for those who have been on the Intelsat program, Intelsat, actually, they manage the largest fleet of geostationary or geosynchronous satellites in the world. And then, of course, we have lunar orbit and we have Mars orbit, where we would have satellites. Sasha, can I hand over to you while we have this graphic up, just to share a little bit in terms of your development pipeline at bluShift?
Sure, thank you, Judy. And just want to take the moment to also say it's been great to have students not only from Jim's class but other schools coming to the cold engine test, cold flow test, and very excited about having more student experiments on board for our next engine test. And actually, if I can take the moment just to talk about that test, because it's really an exciting one for us, and we're actually we're kind of hitting the pause button to kind of make sure we can get these student payloads here in time. So we're actually holding up, for once, we're actually holding up the engine test, not because of us, but for you guys, which is a valuable reason. Doing this stuff for you guys, for students, for teachers, not only in the United States, but across the world is what we're in full alignment with doing with Max IQ. We're very excited about the possibilities of students like some of the folks here really engaging in real science, and yes, real rocket engine and real rocket science. So on that note, what's so exciting about what's coming up May 1st of this year is we will be doing a full engine test. Sorry, it'll be about a 10-second test. And what's happened is last year we went through a number of hot fire tests of our Marvel rocket engine. The Marvel rocket engine is a hybrid rocket engine where the fuel is a solid and the oxidizer is a liquid. And we have about 600 pounds of fuel on board when we ignite that engine. Now, we won't burn it all, but based upon all the tests we did last year, we've learned what we need to change in the engine to make it. We need to make the engine longer, a little bit more fuel. We have to change the nozzle geometry just ever so slightly. We have to change the way the oxidizer is sprayed into the engine and how that's controlled. So all those modifications and all the pieces and parts are coming in right now for assembly so that you guys can be part of that test. So we're very excited about that one. And if that engine burns well, then we will be moving very quickly to do a full burn, another much longer burn, up to one minute. So that is the very next thing you guys can be part of. This is a very important part of our development timeline. As we push to once we get a full engine burn, we will be moving to build the lightweight version of our Marvel rocket engine to incorporate into Starless Rogue. Starless Rogue being the 50-foot long, which is how many meters? Gosh, I should know this, about 16, 17 meters, something like that. Sorry, very bad with meters.
Roughly divide by 3, roughly, yeah.
Okay, so yeah, so like about 16, 17.
16, 17, yeah.
Rather. And about 0.6 meters in diameter. So the plans are to do, and we decided to do this both for us internally as an engineering activity, but also for you guys as teachers and students wanting to do real experiments with on board as payloads in our rocket in Starless Rogue, we're going to do a low altitude launch. And so this is, for us, is sort of an engineering launch where we are basically testing all the systems. Now we're not just testing it tied to the ground with lots of concrete and lots of bolts, but we're going to let it fly off of our launch rail system and go up about, I think it's anywhere between 8 and 10 kilometers in altitude. Make sure the recovery system works, make sure our telemetry works, or the communication system, make sure your guys' part of the rocket works, the payload area, the power, the data collection for you guys. And if everything goes well, one, you'll get your payloads back and your data. Two, hopefully you guys will be able to join us for future launches. And the next launch after that one, the plans are to go full all the way to space, punch it all the way, go beyond 100 kilometers. And that we're anticipating will happen next year, 2024. For us, there's a bit of a lag as we have to go through the FAA approval process for that all the way to space launch. And then after that, our plans are to have a lightweight version of Starless Rogue, which will allow us to go up to 450 kilometers up into space. So you see where the International Space Station is. Now we're getting up into their territory. Now, of course, we have to coordinate that with the FAA to make sure we're doing this in a safe fashion. So we're not hitting the space station, which would be highly unlikely, but that we're doing this in a safe fashion. And the plans are to do that on an ongoing basis to support students like you and the generations to come, and folks like you, kids like you, are developing not only this first round of experiments, but additional rounds. And I'm hoping and expecting that MaxIQ will be developing newer modules and giving you guys more and more flexibility to develop novel experiments that have never been done before in space as we progress along. Now, the plans are within about 3 to 4 years after now, and it all depends on a lot of things, how the engine propulsion system works, approval process with the FAA, et cetera, funding from investors. But our plans are to then evolve into doing adding on orbital launch services. So we'll be launching over the Atlantic Ocean, going south off. So we're located in a state called Maine, which is in the northeast corner of the United States. And if you look at the coast of Maine, it looks over the Atlantic Ocean going south. So we're able to launch into an orbital, it's called a polar orbit launch. And this, it turns out to be a very important orbit for CubeSats. So that is, I think, going to be an extremely exciting moment now for us as a company, but for students. Now you'll be able to not only do experiments for a couple of minutes, but for days, weeks, and months. And I know that Judy's organization, MaxIQ, has some really neat ideas on how you guys will be able to download your data on an ongoing basis, and hopefully from multiple points across the Earth. And we're very excited for that future as well, and all the science you guys may invent to go along with it.
Great, Sasha, thank you so much. Yeah, and I think that if we, I'd just like to go back to that. I'd like to go back to that graphic again. And that is, a number of you are also working on the TinyGS ground station that collects data from satellites using LoRa or LoRa radio technology, and that's really very important from a ground segment perspective and a ground station perspective, because when we actually do launch into polar orbit, we're going to be utilizing that TinyGS network. So you're going to have LoRa radios on your satellites. So now you are assisting others download their data and post it to the website, the TinyGS website. And that growing community is going to be helping you in turn when you launch your satellites to be able to collect your data as you pass over these ground stations. One of the limitations in the past has been that when one launches a satellite, you only have roughly a maximum 18 minutes of exposure, maybe twice a day if you're lucky, to download your data. So that is why the TinyGS community has been developed so that there's people all over the world who can download data for everybody. And so what we're able to do is that now you're able to get, we're really reducing the latency, because if it flies over part of a continent in a remote area and it detects a fire has started, or there's maybe some kind of a plume, then that message can be sent down straight away. We don't have to wait for that satellite to fly over. So, so yeah, Sasha, that's it's all part of the plan. And when Bianca and I were there with you week before last, I remember Bianca spent quite a while with your engineering team, familiarizing them with the Tiny GS ground station, so that they are aware of the ground segment when they design the flight segment.
Very cool. And I just wanted to comment that when we launched Stardust, some irony, not irony, but some coincidence, we looked strongly at using LoRaWAN for our data download for some of the telemetry, even at that time, 2 years ago. So very exciting to see that implemented going ahead for students. Absolutely.
Great. So yeah, before we move on from this, so yes, Sasha, thank you very much for putting a short pause. What we have is we really want everybody's payload to be integrated fully. We do have some teams who want to develop their own code. We do have the opportunity of using the code that was used for the engine test in November last year. That is certainly going to be available to everybody. And as you mentioned, the payloads are fully recoverable because it's not flying anywhere. And so what we did is we participated in a student launch. Some of the teams on this call participated in a student launch in March this year, last month, and those payloads were lost over the sea. And they weren't able to recover it. The winds were very, very high, so they actually weren't able to recover everything. So that was a little bit of a tragedy because we didn't have a downlink for all of the data. So that is why it's really important that we do these engine tests, because there's so much that we can test where we know we can certainly recover before we fly, because we don't know what's going to happen actually on the day. And yeah, so it's part of the essential. It's one of the essential stepping stones to space. And then, Sasha, as you mentioned, those same payloads, or even augmented. They can be augmented with additional MaxIQ sensors, maybe custom-made payloads for when you do your low altitude flights, and when we go for the suborbital flight, hopefully next year.
Judy,
yes, Sasha.
Yeah, I think it's what's been sort of remarkable about the experience in working with the teachers and students to date is that there is so many parallels to what we're doing, where we're just like you were saying, we're testing our engines out before we do the very risky activity of launching the rocket. You want to make sure everything's working right. And it turns out the same happens with the payloads. There's a real benefit to, like, how will this be strapped in? How will this be put into the enclosure? How will it be powered? How do we power it up before you go to launch, or in this case, go to the engine test? What are we measuring? Are we going to be in the right place to measure it? And then, I think Jim was saying, you have a few, code wasn't, the code wasn't running at the time. We forgot to turn it on or off. And these are like really good experiences, especially when it's something that doesn't get lost, or hopefully doesn't get lost. And having those experiences with us, I think it is part of the scientific learning process, where you do things stepwise, make mistakes, learn from it, improve, learn from it, improve, learn from it, improve. And so it's really a delightful time, I think, for teachers and students to be involved, because you're coming along with us for the journey of these experiments. And hopefully you're learning not only for the students that are with you today, but the students to come, the ways to go about collecting data and designing experiments and the like. So anyways, it's very exciting. And I don't know, Judy, if you've already covered with everybody, like where, and maybe the stuff that Cody's covered, but where the students get to place their experiments and the type of dynamics that are going on with these engine tests. Should I explain any of that, or has that already been explained?
I would like you to explain it.
Sure,
yeah,
okay, great.
Yeah, absolutely.
Okay,
Please,
fantastic.
Sasha, go ahead.
Yes. So as you can, our engine, in theory, can peak out at about 20,000 pounds of thrust. And gosh, all the engineering team talks in kilonewtons. And of course, I'm not remembering what that is in kilonewtons. I'm the only one that's stuck in pounds, apparently, in feet. But it can peak out to that level. And this, this next test should be our highest performing engine test yet in terms of total thrust out. But, the engine test cell is a large concrete set of barriers. Think a long shoebox of concrete with a face open at about a 45-degree angle where the flame goes out. So it's a lateral test, a horizontal test. But the students get to mount their tests, their experiments. There's one enclosure that's mounted to the side of our engine. There's also a number of places where you can mount further and further down along essentially the flame, the exit flame, and hopefully not directly in the flame. I know we did have one or two experiments get literally blown away, but not burnt away, which is really good in last hot fire test. But it is loud. It is, there's a lot of exhaust. The last test was a sort of a dirty test in the sense that it was very fuel rich. We didn't have as clean of an engine burn as we like, sort of fuel rich. But at the same time, you didn't see like a large dark cloud of smoke. So it was still a decent burn, but it wasn't. We want it to be quite a bit more oxidized or combusting with the fuel. So there's opportunities for measuring the particles, what sort of gases you're getting there. The vibrations should be intense off the scale. There's even opportunities to measure the light coming off of there. I don't know if there's any ultraviolet measurements, but it would be very odd for us to have ultraviolet light coming off of our exhaust. But there's so many opportunities for doing science here, from the sound levels, the light levels, the gas levels, the vibration, which you can measure, acceleration, humidity. Of course, temperature should be literally off the scale, but hopefully not right where your experiments are getting placed. So basically the way the students did before is you had a couple of experiments mounted to the engine, a couple on the sides of the flame, what's essentially our horizontal flame trench, and then some outside of the test cell, still extremely close to the engine test. You wouldn't put a human there, but of course you put your experiments there. So there's a whole host of things could be measured there, from gases, temperature, humidity, vibrations, accelerations, sound levels. So I think it's really up to you guys and the students to kind of come up with really, interesting experiments, what you could do, what you can see. We'll be doing this should be during the daytime, the afternoon. So, it could be interesting to measure light levels and how that changes during the engine test. It could be there's some imperceivable, but your sensors can perceive changes in the light flux. But certainly one of the more exciting ones will be the acceleration of vibrations you'll see too. So that just gives you, and feel free to ask questions too, if you're thinking about how you want to approach these experiments and what you want to do, and could you do this or could you do that? We're here for you guys too. MaxIQ is building the capability, but we really want to make sure that the experience for you guys as teachers and students is really, you're really getting involved doing real research, doing real science. And so if there's things that we can do or adjust or tweak, maybe we can't do in this test, but we can do the next one. We want to figure out what we can change and do to make it better for you guys as well, and a successful experience. So
Great, Sasha. Yes, thank you very much. Yes, as Sasha mentioned, what we did is we had a few different positions for different kits last time. So we do have a number of environmental sensing kits which have the carbon dioxide and volatile organic compound sensor, as well as a particle matter sensor. We've experienced a really dramatic chip shortage, so we haven't been able to get the particle matter sensors. So the only ones we could get our hands on are actually with Cody at the moment. So we're very limited in terms of those environmental sensing kits. And so probably what will happen is that those will be put out. But I think that for the teams in this call now, and who are going to be participating, your kits your payloads are going to be going into that, into the 3U payload, basically into the payload bay. So they are going to be attached. They're going to be attached to the engine itself. So what you'll be doing is you'll be monitoring actually the conditions in terms of the engine as it's fired up and as it's shut down. So I just wanted to clarify that. But however, that doesn't stop you from putting any sensors that you want to put onto it at all. It really doesn't. And so yeah, the teams have received the extended call. Okay, so here's my extended call. I have a green one. Some of you may actually have some of you may have white ones, but they're essentially exactly the same. The connection to the payload bay is these connectors which we have on the side, and then you've got your normal MaxIQ connectors of 10-pin connectors, and reading the data to the SD card, we can see here that it has an SD card holder. So that is actually where all the data is going to be saved. So what will happen is that the code, you can either develop your own code, or otherwise you can use the code that we used in November. What will happen is that Cody will share that with everybody. And what you could do is you could actually take that code, you could modify it yourselves if you wanted to include other sensors, etc. So one of the things that Ryland, in terms of your project, so let me give a little bit of context to everybody. What Pennsylvania State University is looking at is what they're looking at is how do we increase the rate at which we read the data from an accelerometer. So, you know, the thing is that if we take another sensor, like for example, a temperature sensor, so what we'll see is if we have a sample rate, you know, every few milliseconds, every few microseconds or seconds, whatever it may be, we'll have temperature data, etc., etc. Our challenge with acceleration, especially when we're looking at 3 axes, X, Y, and Z, is that what you need is you actually need these instantaneous readings. And so having the sample rate where you're sampling every 10 seconds or every 5 seconds, that data is actually meaningless because then you don't get that vibration. So what Ryland and his team are looking at is how can they really, really increase that data sampling rate and save it to the SD card? Because, you know, it's one thing to read the data, but then it's also got to be written. So how are they going to do that? So that's a really interesting experiment for them to do. So Ryland, you know, I'm also thinking, you know, you have a number of groups here who are going to have a number of kits. Maybe you also want to have some of them run your code. You never know. You know, so maybe we do something that way. What we could also do is we could have a look at maybe what we do is we combine a number of different data sets. Because if, let's say, for example, if they're not going to be sampling exactly, at the same frequency. So if we sample at different frequencies, then maybe we can actually build a data set over time that gives us more data. So in other words, we're measuring, one measurement is during another one's gap or something like that. So maybe we can collaborate with something like that. The volatile organic compound sensor is a really nice one to use as well, because we really want to be able to test, are we getting complete combustion or not? So I think that could really be great to have a look at that, to use that sensor. So the accelerometer, the volatile organic compound sensor, the barometer is also quite nice. If we think about it, we're expecting the engine, with all of this energy and all of the, with this exhaust, we're expecting some kind of a Venturi effect, or what is that? It's not in a pressurized payload bay. So the barometer could really be an interesting one to use. And that sensor board will also give us temperature. So that could be quite interesting. I'm not sure if anybody's on the call who has done a specialized payload for the high altitude balloon launch. If you want to share that with us, since you're going to be using that again during the engine test. I'm not sure. I see that Jack unfortunately needed to leave us. Jim, does your team have a specialized payload on yours?
We did. We added, what did we put on there? The accelerometer, but we didn't have it check very often. I think it's every 5 seconds, because we weren't sure how long the flight was, and it's just a balloon going up. So it was really just to see if the balloon was still moving or not. And then if it wasn't, shut it off and it move at a slower rate, at least for data detection. We used light and UV, what we were testing for, CO2 and volatiles as we went up. We were collecting that data to see what was in the different layers of the atmosphere, if it changed at all, the barometer as well. And I think the weather sensor, and that was it. I think that's what we put on there.
Okay.
It's sort of interesting, Jim, that what you want to collect for data and how quickly the sample rate really depends on the environment and the conditions of the experiment. And so, Judy, you're just talking about sampling at a much higher level for acceleration, much higher rate. But certainly for a balloon launch, it makes sense. You wouldn't want to do it all that much, probably. So it's an interesting concept of, it's not only about what you're measuring, but I guess how you're measuring it, and how often you're measuring it. What makes sense based on what you expect.
How much battery life you have, all that. We weren't sure of the parameters. So we're like, well, we take it every couple seconds. That'll be, fine, hopefully.
Right.
Yeah, absolutely. And also the same thing is, sometimes what you want to do is you want to use your accelerometer almost as a watchdog. That what it does is that you have your payload in like a sleep mode, or a very ultra low energy mode, and it's only when it starts to move, it's like, oh, okay, something's happening now. Because one of the huge challenges with student payloads, satellites, is that they can sit for months waiting for a launch, and when they get launched, the batteries are flat. We had one of the ThinSat launches that we had. 17 of those satellites, the batteries were flat. Nobody had charged the batteries before integrating them into the Cygnus module. So sometimes you actually want to have it so that you can control your own destiny in terms of your having your power. Yeah, Jim, thanks a lot for that. We also have another question here in terms of from the group, in terms of the Kibana dashboard. We're not going to be able to use the Kibana dashboard for this test directly. Okay, so and let me just explain. With the Kibana dashboard, what it is that when we successfully connect our core, our ESP32 to Wi-Fi, internet, and then internet, that data gets posted to an MQTT server, which we host in North Carolina. And then that data itself is presented on the Kibana dashboard. So that is all built into the code for example, the starter kit, the STEM kit. It's built into that code that what it does is once you've configured it for Wi-Fi, then it actually posts that data to the MQTT server so that we can view it on Kibana. In this case, we are not going to have any Wi-Fi connectivity. We're not going to have any internet connectivity for the kits. So they won't be able to post any data that, to the MQTT server. So we're not going to see it on Kibana. All of the data needs to be saved on the SD card on the extended core. So this SD card holder, all the data is going to be saved on the SD card. However, what we can do is we can take that data after the fact from the SD card, and Bianca can upload that to Kibana. So, and what we've done is we've done that in the past. So for example, in 2021, when we had a kit on the International Space Station for actually exactly 28 days, exactly 4 weeks, in February 2021. And what it was is that kit collected data on the atmosphere inside, the air conditions inside the International Space Station. It collected data, posted it to an SD card, and then that payload actually came back. And so what happened was that Bianca recovered the data from the SD card, and then what he did is he saved that to the MQTT server in a particular index. So we will be able to do that. So it's not going to be live. We won't be able to monitor it live, but certainly we'll be able to save that data. If you want your data saved to the MQTT server, we can certainly do that, because then it's so nice. Then you can actually use the Kibana dashboard for your visualizations and things like that. So it is possible, but it's not going to be a live feed. It's going to be very much asynchronous.
And Judy, I know with the cold fire test, at least, all the acceleration, the raw acceleration data was subject to ITAR, so International Trade Arms and Regulate, whatever it is, international treaty. So we had actually, it kind of threw us for a loop because we're not set up for that here. We use all Google stuff, so we had to like find back alleys and stuff like that to actually work with the data. And the file is huge, right? The number of data won't
it's huge.
Excel chokes on it. So yeah, so Python and stuff like that might be interesting. So I don't know if you can post. The other data might be fine, but Sasha probably knows more than me, but I know we had an issue with that, at least the acceleration data not being posted on any system anywhere.
Yeah, it's funny. Acceleration is probably one of the more interesting bits of data to gather. And we have been back and forth with an attorney and now sort of an expert in the arena of what's called ITAR. Even though ITAR is the International Trade in Arms Regulation, I think is what it stands for here in the United States. And even though, we're obviously not, our rockets are not meant to be weapons, they fall into the classification of such. So we have to follow the federal rules, but there's a lot of vagueness because the data that's being collected is it's very difficult to say, could somebody reverse engineer our rocket engine? That's where we could have problems. So so I think that we are very close to kind of finalizing what we can share or not share with regards to acceleration data. I know David, my CTO, is working with our consultant on clarifying that. So stay tuned. I still would recommend trying to collect that data because, and then maybe it's something we can't share at the end, but it's so interesting. I gotta imagine you would want to at least try to collect it. So
yeah, Sasha, absolutely. Jim, yes, you bring up a really good point. If I look at it from my perspective, yes, as somebody from outside the US, I agree. You know, the lawyers are always going to feel that everybody can reverse engineer everything. I think that's maybe because they've never had to reverse engineer something and they don't realize actually how difficult it is. It's their theory. However, that being said, for me, what's really actually the learning and what's for me, what's really important is that it's all around getting the code right and getting the sample rate high enough, writing it to the SD card, making sure there is data there. You know, so what it is, basically, we have a sensor that can give us data in X, Y, and Z. And how do we actually save that data? How do we write that data to the SD card? Because this is all about our future missions. So, Sasha, the actual vibration profile is not as important as does our code work. Also, the thing is that from a mechanical perspective, we really want to make sure that our payloads can handle that environment. Yeah. Going back to what Jim said at the beginning was that, you know, something shook loose for them. You know, so we need to make sure from a mechanical perspective that everything will work, that are from a code, from a power, communication, all of the other elements, that's what we're testing. We're not actually looking specifically for your vibration profile. Or your engine profile. So, you know, the thing is, it'll be interesting to see maybe what the trends are. You know, can we detect when you know, you turned off the oxidizer, for example? Can we tell from the vibration maybe the consumption of the fuel? You know, because none of these things, nothing in nature is ever linear. There's always a curve. So yeah, I think there's a lot that's really interesting without us having to actually look at the data itself. If we look at the trends that the data is showing us and whether our code's working and all of that kind of thing, I think that's really what's going to be important. Do we have data or don't we have data? I think that's what it's more about rather than the actual data itself. I don't know, I think I'm repeating myself. So yeah, I think that then maybe in terms of Kibana, what we would do is then maybe we're not posting the acceleration data, the data from the accelerometer to the Kibana dashboard, but we're posting all the other data, which would really be interesting. So, you know, one of the things that we did do that we were on when it came to the International Space Station, you know, what I should do is maybe I should redo that video one day. It was really interesting. What we found out was that, you know, it was measuring, the kit was measuring the microgravity because we had the same accelerometer on it. It was measuring the microgravity in micro Gs. And then you could actually tell when the ventilation system was turned on and off. And what would happen is that the CO2 levels would creep up and then they would get to a point where they would just drop. And when we compared that with the vibration data, we could see, wow, there's something's being turned on here. So they're turning on some kind of air cleaning system based on the CO2 level. So it was really interesting, that data, just to see from a micro G perspective those changes over time. So So yeah, maybe what we do is maybe we just take that data and we interpret it as maybe, pitch your role GeForce, something like that, instead of actually the raw data. And then we look at that. So that's maybe something we could do. Okay, so let me quickly, we need to conclude. It's getting darker and darker around me. We have a power failure at the moment, but I have plenty of internet and battery. But that's two things I never run out of. And coffee in the thermos, Sasha. Coffee in the thermos. Okay. So the logistics. If you're in the USA, Jim, Jack, the team from Pennsylvania State University, Cody is going to send you a shipping label to ship your kit to him for the launch. If you have your kit on the high altitude balloon launch with Daniel Lee on the 16th of April, if you don't want it back, if you want it to go straight to Cody, then that's fine, because it's going to go to Cody anyway. So just let Cody know that he mustn't send it back to you, that he must rather keep it. So if you're not in that situation where you're going to be sending a kit to Cody, what we'd like you to do is to flash your code onto the ESP32 core. I've referred to it in its technical name. The extended core is actually called the CWV. And then insert your SD card and ensure that the SD card is actually working, that you're saving your data. So in other words, your code does work. And then ship your payload with your SD card inserted to Cody. And the deadline is he needs to have it no later than April the 28th. So to be safe, ship it to him before April the 24th. USPS is very, very reliable, and we're very confident it's not going to take more than 4 days to get to him. But now, really importantly, for those of you who are outside the USA, because of the time constraints we have on this particular engine test, we're not going to be able to accommodate any non-standard X chips. So for any of you who have taken these prototype boards, let me just get a prototype board here out of my kit. Let's say maybe, for example, you've considered using one of these boards to actually build your own components, or maybe even one of these that connects to that 20-pin port on the extended core. We won't be able to use those for this particular engine test, unfortunately. But if it's the standard X chips, the standard white X chips, we can definitely do that for you. We also probably not going to have time for you to send your kit to Cody. So what's going to happen is Cody is actually going to assemble your kit for you on his side. But what he needs from you is he needs to know what sensor boards you're using, which X chips you're using, and also he's going to want your code. If you're going to be using the standard code, that is fine, but I would really, really recommend that you flash your core with that standard code. You make sure that it writes to the SD card, that it works with the sensors you've chosen, etc. Because nothing is perfect, and you never know. You may decide to use an additional sensor to one that was used in November last year. And so what Cody needs is he needs your code to be with him by the 24th of April, because what he needs to do is he needs to flash a core on his side, and he needs to test your code and make sure that your payload works, and then to integrate that. So I think with that, I'd like to know if there are any questions before we conclude. Thank you, everybody. And if you need to catch up, just please pop me an email, and if we need to set up another discussion. So thank you so much. And thank you all for taking the time out to join us today.